Alright everyone, welcome again. We continue to look at the different types of electronic components. For today, let's look at something that is used very widely, the component known as a capacitor. These are very useful devices. You will find them being used a lot, and practically every electronic circuit will have some or the other kind of capacitor. Now functionally they have different purposes and how they operate. At the base of it, what a capacitor does is it stores a certain amount of charge. So if you apply an electrical voltage to it and you remove the voltage, it is a sort of a battery for a very short period of time. It cannot store a lot of charge and it cannot run for a very long time, but it does in a very simple sense work like a battery. And because it does that, obviously different values of capacitors will have different charge retention capacities. So if you look at these two devices that you see right here, this one is known as a disc ceramic capacitor or just a disc capacitor, and these come in usually lower values, and their purpose is not so much of storing charge as to filter out and eliminate noise or signals, or to act as a element in a filter. For example, if you are having a low pass or a high pass filter, then these kind of low value disc capacitors are used. And there is a big range of capacitors. I am not going to walk you through all, but just show you two of the very typical ones. So these are used mainly for filtering, noise reduction. If you have, let's say, a switch or a push button that's connected to an Arduino, you will notice that when you press the switch, you will get multiple switch events being recorded by the Arduino. That's known as an effect known as debounce. So when the switch closes, because it's a mechanical device, it will close and open and close again for a couple of times before it settles. So that's debounce. The switch is moving pretty fast, and each of those events gets recorded as multiple switch presses by the Arduino. So you want to avoid that. There are ways of doing it in code itself. The debounce code is pretty commonly used for in Arduino, but you can also do it externally by, let's say, adding a little small capacitor across your switch, which will improve the performance of the circuit by reducing the noise or the debounce. So there are many different ways that the capacitors get used. So the smaller ones like this do that. The larger ones that look like this kind of a can, and if you look at it, it has polarity, just like you looked at the LED, which has a positive and a negative polarity. These are known as electrolytic capacitors, and there are again a different wide range of polarized capacitors. These ones are one kind. They will have the negative terminal marked. Again, just like in the LED, the negative terminal is short, the positive terminal is longer, and they come in all sorts of sizes and shapes dependent on two things. One is what is its capacitance. In this case, this one is 100 microfarads. So 1000 microfarad will be much larger than this, and its voltage. This one is 25 volts, but a similar 100 microfarad 100 volt capacitor might be slightly larger. So these can actually act like a sort of a battery. Like I said, when you apply voltage to it, it will charge up, and then when you remove the voltage, it will slowly discharge. It will be like for a couple of milliseconds, depending on the size, up to a couple of seconds if it's a very large capacitor. And you can notice that effect if you use, let's say, I'm going to show you a circuit on your screen. So here it is. This is we've wired up an Arduino. Actually, you don't even need the Arduino. All you need is to supply an LED through a resistor, and then across that whole circuit you connect a capacitor. Let me show you the schematic that makes it easier to understand. So here's how it is. You have a battery and you have a switch, and then to turn on the LED you have to limit the current, so you have a resistor, and then across the resistor and LED pair you have a capacitor. Now what happens when you turn on the switch is the current flows through the resistor and the LED and turns on the LED. but at the same time it also charges up the capacitor to whatever is the level of the battery voltage, maybe 5 volts, 9 volts, 6 volts, whatever it is. And then as soon as you turn off the switch, there is a certain amount of charge stored in the capacitor because of its value, and the larger the value, the more the charge it stores, and then that passes through the resistor and the LED and keeps the LED on for a very short duration even when your switch has been turned off. So that's an interesting characteristic that is used. These kind of capacitors are used for a lot in power supplies. I'm going to show you a couple of typical circuit boards. Here's one board which has a whole bunch of capacitors. There's one here, that's a noise or a low capacitance filtering capacitor. There's a whole bunch of these green capacitors here. And here's one large one that is probably a pretty high voltage one. Let me turn it around and see what value is written on it. So this one is a 350 volt 10 microfarad capacitor. So the capacitance of this is much lesser than this very small capacitor. This one is 100 micro, this one is just 10 micro, but this is 25 volts and this is 350 volts. That makes a big difference in the size. Here's another capacitor, here's another one, and you can see the circuit is like sort of populated with lots and lots of capacitors at different points along. Here's another old circuit I picked up. This has just another capacitor. Here's one over here. Here's a second, here's a third one. Here's one more over here, one more over here. So you can see these little disc capacitors, they are all the noise or the decoupling capacitors, and the bigger ones are for filtering purposes. A little bit later, sometime later, we will look at an actual circuit where some of these components come together, and in that circuit we'll explain how what is the importance of a capacitor like this. So until then, keep learning, and I'll see you later.